it said that an object is thrown at a velocity of 45 meter per second at an angle of 45 degree, and 2 seconds later another object is thrown at a velocity of 50 meter per second, and the angle is same actually, alpha 2 is also same at 45 degree. So after how many time the second one will land, that's what we have to find. It is already thrown 2 seconds later. So what we can do for the first one, let's say, we know that this equation is we can write this equation, and we know when the object reaches the maximum height, the vertical velocity becomes 0. So, and maximum height it reaches just half during the half time of the total travel time. So basically this one t and uy over g, so uy is 45 sine 45 degree over g, which is 9.8 meter per second. So we can write that, and this one is when it reaches the half of the interval, half of the travel path or whatever. So the total travel time will be t1, if we say, that will be 2 times this one, which is 2 times 45, 90 sine 45 and 9.8 there. So this is t1 for the first one, and for the second one t2, if we write, it will be the same thing. So it, instead of, since the only thing that changes is the velocity, so that's 50, and sine 45 degree is still the vertical, and 9.8 meter per second. So we can see that this one takes more time, the second one, of course, because the velocity is so the difference is, if we write del t, the difference will be t2 minus t1, and also that it is already sent 2 seconds later, so plus 2 seconds. So t2 minus t1 is 100 here, and then sine 45, that's 9.8 minus 90 there, sine 45 over 9.8 plus 2. So that one is 10 and 9.8 if we subtract it, and sine 45 is 1 over root 2 and then plus 2. So if we do the whole thing, it becomes 0.7 and then plus 2. So 2.7 seconds later the second one will land. The second one, if they were thrown at the same time, the difference would be just 0.2 seconds, but as the second one is thrown 2 seconds later, so it will land 2.7 seconds later.